We are playing a game, and our goal is to analyze the expected value of 3 different strategies. The game is, we have $1 in one envelope, $2 in the second envelope, $3 in the second envelope, $4 in the fourth envelope, and $5 in the fifth envelope. And then we mix them up randomly, so we have no idea where the money is. Now we will use 3 strategies to help determine the expected value of our envelopes.
So for the first strategy, it's called random strategy. So as we mix up the envelopes, we lay them all out. I'm just gonna pick any envelope randomly, choose this one, and there's a value of $2 in this envelope. So I get $2 and keep it. So now if we go to the math over here, random strategy, you just do the expected value of all of the values and the probabilities. So for example, the value of 1 times the probability of 1/5, because there's 5 total envelopes. And the expected value for all those envelopes is 3. So you expect to get 3 most of the time. So the next strategy is single reference. So I'm gonna mix up the envelopes again. So let's mix them up really well. Look at that. All right, I'm gonna choose this one. So this has a value of $4 in it. I'm gonna write that down, so I'm gonna keep it, but I don't get the money. I'm just discarding it and remember that I had $4. So I'm using that as a reference. So now I want $5, right? So if I open the remaining envelopes out one at a time, the moment I find one that beats the reference, I stop playing and I keep it. So for example, this is $5. That's the highest amount. So I want to keep $5 and I get win. So now if we go to the math, single reference goes like this. For example, if you pick 1, then you lose that envelope and you have 4 envelopes remaining, changing the probability. So you take the value of 2, 3, 4, and 5, which is what's remaining, and you multiply it by the new probability, so that's 1/4. And so that, if you choose 1, the chances of you getting an envelope is around 3.5 is your expected value. It goes on for all the rest of them. So if you pick 2, you lose an envelope, your expected value is 4. Pick 3, you lose another envelope, your expected value is 2, it's 4.5. If you pick 4, like I did, my only chance of is getting 5 times 1, so I get 5. So the next strategy is single reference. And that's when you keep the first envelope that beats another reference. For example, I'm gonna mix these up again. Cool. Pick one. I got $2. So this is my reference. So I'm just gonna discard it, but I know that I have $2. So there's 4 envelopes left. And I don't want 1, obviously. I'm gonna pick something that is higher than my reference. So, for example, 2 again, pick this, 5. Man, I'm really lucky. So for example, I would keep 5, obviously, and stop playing the game because it's the highest of all of them. Let's go look at the map over here. So for single reference, for example, I chose 2. So there's 3 left because I obviously don't want 1. I discarded 2 and I don't want 1. So there's 3 left. And you do 3 times 1/3 plus 4 times 1/3 and so on and so on. And your expected value is around 4, but I got really lucky and I picked 5. And it goes on for the same thing. If I pick, for example, 4, I don't want anything that's less than 4. So I don't want 1, 2, or 3. I want 5. And if I keep playing and discarding all the lower ones, then the chances that I will get 5 are very high. So the next strategy is double reference. The same as single reference, but you open and discard envelopes A and B, and your reference is the higher of the 2 values. Then play as before, keeping the first envelope that beats your reference. So I'm gonna mix up these envelopes really well. Beautiful. I'm gonna take these 2. Let's see what I get. I have a 3 and a 4. So obviously, I'm gonna choose the 4 because that's the higher of the reference, and discard these 2. And then you keep playing as before, and you want the highest number. So let's go over here. Here is double reference in the expected values. So for example, I picked a 3 and a 4. The only one that I want left is 5, so I'm just searching for the 5, and the chances of that is the expected value is 5. And for example, if I got a 1 and a 2, what's left is 3, 4, and 5, because I would choose 2. And the expected value for that is 4. It goes on for the same thing. If I chose a 1 and 3, obviously I'd pick 3, and I don't want 1 and 2 because that's lower. I have 4 and 5 left, and my expected value is 4.5.
Am I good right here?
Yeah. In this situation, I don't really need to choose another way. Can we do this whole?
You guys good.
So, hold on.